Hi guys, so today we'll be solving this problem called first completely painted row or column. Let's read it. You are given a zero index integer array and an m cross n integer matrix. Array and matrix both contain all integers in the range 1 to m into n. Go through each index I in array starting from index 0 and paint the cell in matrix containing the integer array of I. Return the smallest index I at which either a row or a column will be completely painted in a matrix, right? So pretty simple. We've been given an array which has values from um, 1 to m cross n, and we need to color this matrix using each value from array one by one. And uh, once we have done that, we need to return the smallest index I. So this is 0, 1, 2, 3. So smallest index I, which is required either to paint an entire row or an entire column. So, which means, so let's say we are on 1, right? So we go here and 1 and we paint 1. So I'll just use green color to paint this 1. Then I'm on 3. I'll go and paint 3. Then I'm on 4. I'll go and paint 4, right? So if you see, you only need to travel till index 2 to get either a row or a column to be entirely painted. So here we return the answer as 2, which is the smallest index that we need to paint either the row or the column, right? In the second example, if you see, you have this array and also this matrix where you need to do the same thing. So you need to iterate through array and paint the matrix. And if you see, we are able to get the 2, 4, 7 as painted at index 3 itself. So 2, then 8, and then 7, and then 4. So 0, 1, 2, 3. So you hit the third index and you are able to paint an entire row, entire column actually. So that is the idea, right? So the approach for solving this problem will be that it's very interesting. So yeah, we can basically run a brute force, definitely, right? Where we go through the matrix and paint each column using the array and see if it's actually containing the entire row or not, right? So, but that's time consuming a bit, right? So what we can do is use this array and store it in a hash map, right? So here we'll have index key value pair as key is the array value, right? And value would be the index that it's on. So 1 is on 0, 3 is on 1, 4 is on 2, and 2 is on 3, right? So key value pair, right? So that is the approach. So using this, we'll go through the matrix. In that matrix, what I'm going to do, so I have 1, 4, 2, 3. I'm taking the first example. So first I'll iterate through the rows, right? And I'll pick up, so when I'm at 1, right? So when I'm traversing the first row, I'll go to 1, I'll check whatever is the index, I'll store it in the temporary variable. So this is 0, right? Then I'll go to 4, check what is the index 2. So the temporary index gets updated, which means that I'll be storing since I'm iterating through the row, I'll be storing the maximum index from the map or the array to make this completely painted. right? So that is the idea. Similarly, I'll go through the second one. So 2 is 3, right? And 3 is at index 1. So I'll store the maximum one. So 3 is the maximum. And in the first row, you got 2 as the maximum, right? So which means that the minimum index, I need the minimum index out of these because I need the minimum or the smallest index at which either a row or a column will be painted, completely painted. So minimum out of these two will be my answer for the row, right? So the smallest index required to paint a row, right? Similarly, what I'll do, I'll iterate again, but this time it would be column, right? And same stuff. I'll maintain a temporary variable which will store the index. And in this column, whatever is the smallest index, right? So 1 is at index 0 and 2 is at index 3, right? So yeah, sorry, the largest value, largest index in this column, I'll store that value, right, in the temporary index. Similarly here, 4 and 3. So 4 is at 2 and 3 is at 1. So the smallest is 2, right? So the largest is 2, sorry. So temporary index actually will be 2 and 2 will be chosen as the basically the minimum required or the smallest index required to paint a column, right? So three things. First, we'll put it in a map. Second, we'll iterate through the rows and store the smallest index required to paint a complete row. And I'll iterate through a column to store the smallest index required to paint an entire column, right? So that's it. That is the idea. Let's get to the coding part. So first of all, I'll maintain a frequency map for storing the array index. So I equal to 0, right? And then I have to maintain a min row index, right? Which is the minimum required for making the entire row painted. So matrix dot size, I'll just iterate through the row first. And in this, I'll maintain a temporary index, which will be basically the storing the maximum index, right, required to paint an entire row. So whatever is the maximum between for the frequency map of matrix of I and J will be stored here, right? Then go ahead and max row, actually min column index will be basically iterating through the entire columns of the matrix. So I'll go through the matrix. I'll maintain a temporary index again here, which will be int minimum, and I'll just iterate through the J, and temporary index, same stuff, will be storing, actually, sorry, max of temp index and the frequency map of mat of J and I, right? So these two will basically go through the row and go through the column. Find me the maximum index required in each row, in each column to completely paint it. And then Here, I will store minimum row index is minimum between minimum row index and temp index. So whatever is the minimum out of all the rows and all the columns, right? So minimum call index is equal to minimum between call index and temp index, right? And in the end, I just return the minimum between minimum row index and minimum column index. Whatever is the minimum between these two will be my final answer as the smallest index required to paint an entire row and an entire column, right? Let's run the code to see if everything is working fine. That works. Cool. That is submitted. I hope you guys understood the problem. Thank you so much.